everyone. Let us try to solve this geometry problem. Now we're given two externally tangent circles that are congruent to each other, each having a radius of 1 unit. We're going to find the area of the yellow triangle found in between these two circles. Now, the area of a triangle is given by the formula 1/2 base times height. As you can see, the base of the triangle lies along the radius of the two circles, and the radius happens to be collinear. So what we're going to do here is we just add how many radii comprises the base, but since we're given the measure of a radius which is 1, then the base is readily given. So the problem now is how to find for the value of h, or to find the measure of the height. Now, the height of a triangle is usually from the apex to the base, and it is usually a perpendicular segment. Now, when you have a perpendicular segment to a triangle, you always have to think about the Pythagorean theorem, especially considering the fact that it is the h that we are looking for. So, the only way, since h is perpendicular, the only way to solve that is we're going to use the Pythagorean theorem. But for the Pythagorean theorem to be directly applied, we need to find the values of the two other legs. This one is the base. Again, it's ready for us. But this one here, we don't have the measure. So that means finding the height using the Pythagorean theorem directly will not work. That means we need to find auxiliary segments that would define another triangle that would be essential to solve for the height. One of such triangle is formed if we're going to draw a line from point H to point D. Now, as you can see, this one here is the radius, and we know already the measure of the radius, that is 1. And another thing is that our radius, if you can recall the theorem about tangent circles, the radius is perpendicular to the circle at the point of tangency. So this HD is perpendicular to AH. Therefore, they form a right angle, which means that this triangle here, triangle DHA, is now a right triangle, and this time we can now use the Pythagorean theorem, because again, remember, if we consider this measure as x and y, and this one here is actually the hypotenuse of this triangle here, but this is consists of the radii of the circle, each having a measure of 1 unit, so this will be 3. And we can name this as x. Now this one is y, but we know that the measure of y here is 1 because that is also a radius. So using the Pythagorean theorem, we now have x squared plus y squared is equals to 1, 2, 3, which is the hypotenuse, that's 3 squared. So we have x squared plus, again, y is 1 because that's a radius, so you have x squared plus 1 squared equals 3 squared. That's x squared plus 1 equals 9. That gives us x squared equals 8. So you now have x is equals to square root of 8. So you now have the value of x. We simplify that. That's 2 square root of 2. So we just put it here. That's 2 square root of 2. So you now have the length of this one, 2 square root of 2. Now we're ready to find for the height. So we simply draw that one. And again, this segment here passes through the apex. At the same time, it passes through the point of tangency of the two circles. So again, by the radius perpendicularity theorem, the radius is perpendicular to the circle at the point of tangency. Therefore, this is perpendicular, and therefore this forms 90 degrees. So now you have this one here. Notice that there are two angles here. You have angle 1 and angle 2. And remember, since this is a right triangle, then this angle 1 and angle 2 are complementary. So that means the complement of angle 1 is angle 2. That means if we consider this triangle, since angle 1 is a part of this smaller triangle here, and based on the given on the larger triangle on the given figure, the complement of angle 1 is angle 2. Therefore, this angle here is a complement of angle 1, and that is also angle 2. So you now have similar triangles. This big triangle here and this small triangle here. Let's create a proportionality ratio now. And using the height, because again, this is now the height. So we have y over h, because again, in similar triangles, the corresponding sides are proportional. So these two sides now are corresponding. So you have y over h is equals to this side here, square root of 2 over 2 over the side corresponding to this is this one here, the longer legs. So that is now over 2. Now, since y is 1, because that's a radius, that's why we now have 1 over h is equals to 2 square root of 2 over 2. Then we have h now is equals to square root of 2 over 2. So we are now ready to find the area of a triangle. Again, the formula is 1/2 base times height. We just substitute. That's 1/2. Our base now is 4 because you have 1, 2, 3, 4. And then height is, of course, we have square root of 2 over 2. The 2 and the 4 cancels out, leaving square root of 2 as the area. The problem is solved, and that is now our answer. So the area of the triangle is equals to the square root of 2. That's it for this video. Please don't forget to like and subscribe to our channel for more challenging geometry problems. Thank you so much. Enjoy learning.